Thank you for coming. There are definitely some wonderful sessions at Strata this year, so I really appreciate you choosing to hear what I'm going to talk about on this time slice. Hopefully, it will be interesting, not promising anything. So, I'll put an agenda. It's more for you to follow, so if you fall asleep or something, at least you have a good idea when I'm going to get over with it. So first I'll introduce myself. I'm going to talk about this concept, economic graph, and what's kind of LinkedIn's vision, because some of you, probably most of you, are not familiar with this concept, and kind of helpful to understand what's kind of LinkedIn is about in order to understand why do we need this thing called the economic graph. And then I'm going to talk about my work in the kind of past year or so in actually building the foundation for this mega vision to happen. Since, like I said, it's very hard to take a year of work of an entire team. Wasn't just my team. I will be talking about just one part of it, but we are a full team that kind of works on it and kind of condense into 30 minutes. So we'll be talking about kind of selected topics that I found interesting. So I will give a high-level overview about how we kind of solve the problem. And I'll also kind of touch on select topics. I'll summarize, and then I'll summarize again, which is just kind of final words. By the way, when I get, so the agenda will be following me through the slides. I think because it's kind of large whole, and in order not to repeat the questions, when I get to this final words and you kind of know you have a questions, it would be great if you can just come up to the mic and just wait for a minute, and I'll be done. Okay, so let's start. So, like I said, I'm Vitaly. I was raised in Israel. I've been kind of more than 20 years there. From my name and kind of accent, you probably can infer that I was born in the Soviet Union. So when people ask me where I'm from, I said, well, from the former Soviet Union. I have just, on my flight to the US, I had a very long layover of slightly more than 20 years. So I went to school in Ben-Gurion University, got a computer science degree. I went to grad school at the Israeli Institute of Technology, got my degree that, well, if you promise not to share with anyone, because I tend not to tell it to other data scientists, I have an MBA degree as well, but please keep it to yourself. If people ask you, I never went to grad school. I work at a company, LivePerson, who is actually based here in New York. It's a chat company. Probably you might have encountered it if you kind of talk. There are actually many former colleagues of mine that came to listen to me talk yet again. Thank you very much. And I was the first data scientist team there. I founded the data science team. We built the Hadoop cluster. It was all great fun. Then I went to LinkedIn. I've been at LinkedIn for 2 years. The last year, I was leading the data intelligence team. It's kind of a fancy name, but I will kind of help to explain a little bit what the data intelligence team does. And the reason I said I've been at LinkedIn for 2 years is because actually this week, and basically a couple of days ago, I started to work as a director of data science at Salesforce, which we now started there a new group to do some awesome stuff there, and I'll touch a little bit on that. However, in case you have nothing to worry about, all the talk will be about stuff that I've done at LinkedIn, because, well, to be honest, I've never done anything yet at Salesforce besides attending conferences. So let's start. Oh yeah, sorry. So I tweet at Big Data AC. That's where you can find me on LinkedIn. Use it. So also what I like to do on my talks is I like to explain, okay, what you can hope to get from this talk, because a lot of time it happens, not at this conference, but at many others. You come, you listen to a talk, and midway through you understand, oh my God, it's not the talk for me, what am I doing here? So here I'll help you to leave the whole much sooner than you probably usually will. So the first thing we'll talk about how LinkedIn basically takes a massive vision, but this massive vision is has to be broken down into very small data problems. You cannot just start executing on that vision before setting the foundation first. And this foundation is what the data intelligence team at LinkedIn does. The second thing is I'll talk about what I think, and there are different numbers everyone quotes. I think it's like about 90% of what we do is basically data munging, data wrangling, data jujitsu, however you want to call it. But it's not the fancy stuff that people do on Kaggle. It's actually working with a lot of data. And as you will see in my talk, when you have 300 million members, and these 300 million members basically fill in their own data, which also, we can call it user-generated content, it becomes extremely, extremely messy, and that is the kind of hard problem that we have to tackle. And the third thing, because it's a kind of a big thing, and everyone have a love-hate relationship with that thing, is I will also talk about endorsements. And maybe you will finally get an answer of why, your family endorses you for stuff they know nothing about. So, and of course, what's in it for me? I love to talk, I love giving talks, I love sharing, my work, but I'm pretty new at it. So I have just one request, and, it will be great. That's my Twitter handle. If you can tweet and let me know what do you think about it, if you, love, hate, anything, any type of comment, suggestion you just have, or, like Vitaly's awesome is a great place to start. And I would definitely appreciate it. So LinkedIn's vision, is, I won't have to ask you to guess it because I don't remember it most of the time myself, but it's create economic opportunity for every professional in the world. That's how LinkedIn started. That is still how LinkedIn sees itself today. We are trying to basically help, other people, and especially, we are a professional social network. So we kind of have this niche, and, we want to do the best for every professional in the world. And part of it is this grand vision of the economic graph. So what is the economic graph? It's kind of a concept that is hard to understand, but it looks something like that. So you can think about different entities that LinkedIn handles. It has companies, it has members, it has schools, it has positions, it has jobs, and they all somehow connected. People connected to each other, people report to each other, they are working at a company, they went to a school, and they hold certain position, they apply to some jobs, they had jobs before, and this is how we want the graph to look like. Unfortunately, and that I kind of touched on before, when we have 300 million members and we trust them to enter that data, and of course they do not do it for us. One of the things that was most frustrating to me about being a data scientist at LinkedIn, and probably a lot of you are LinkedIn users, so I'm now conveying this information to you, is for some reason what LinkedIn members optimize for is not making my job easier. It's for some other unknown reasons, like, for example, display them. So, they don't do a very standard way of entering data, which is, again, makes my life a little bit harder. But let me just explain what do I mean by harder. If we take the position of CEO, there are multiple ways to say you are the CEO of a company, or what people usually mean, and believe me, this list is much longer than that, is sometimes what I actually interested in is not just the CEO, but what people try to signal by saying the three-letter combination CEO is I'm, the main person at that company. And there are many reasons. Like, for example, if you take, higher education, how many of the universities you attended had CEOs, right? No, they have presidents. Or if you take law firms, they also don't have CEOs. They have, senior partners or managing partners or whatever. But so, this list goes on, but basically it means the same thing. Another example of, some tiny startup that has been around for a while, it's IBM. And just some, examples of how people that work in IBM run their company. And that's, again, it's a tiny example. The actual count of unique ways to represent IBM on LinkedIn data is around 17,000. So the 400,000 employees that IBM has on LinkedIn found 70,000 different unique ways to write what company they work for. And of course, I'm counting here like IBM Canada, IBM India, some subsidiary companies, but still they all work for this one. And just kind of the first example is schools. Again, a very short list of kind of how people write on LinkedIn that they went to UCLA or one specific school in UCLA. And you may ask yourself, okay, so what's the problem? Why do we need them to write it in one specific way? So the problem, if you look at this graph, two people that work at the same company are one on the edge. But if one person works at IBM and one works in international business machines, then it's hard for me to draw the edge just based on text. So this graph will be, much sparser and have have much less edges between people that I would like. Okay, so yes, it's honestly on the internet, it's not, these people are not really not honest, but it's just people represent themselves in very different ways, and again, that makes my life harder. So let's see how we solve this problem, and then we'll be touched. So the array of problems my team was handling is even larger. We had skills as well, and I thought, knowing that ROR and Ruby on Rails is the same thing, that we also, people who share skills, and many other things. But I will touch on one thing today, and this is just an example of why we need it. And this is an actual kind of screenshot from something that's called the LinkedIn efficient marketer guys or something like that. Is we hand out this booklet to people who buy our premium product, is how to search for people on LinkedIn. It's mostly recruiters because 60% of the revenue comes from recruiting, but you can see there. Use the or word, and one example is vice president or VP or V.P. or SVP, VP if you're looking for a VP. That's how we tell them to search. Or if you're looking for account executives, then you should look account executive, account manager, sales, blah blah blah. So this is my reaction. It really makes me sad as now a former employee of LinkedIn, but that this is the experience that we give them. We can do much better than that, and it's hard, but I think we should definitely aim to do better. So let's see how we make sad kitty, happy kitty. It won't be very happy, but it will be somewhat more happy. So kind of one solution that we've been at LinkedIn for a while is more like a text solution. If we take the VP example, then first we can apply some acronym expansion. So VP and vice president will be standardized to the same canonical term. We also can do it with abbreviation, SR dot to senior, right? Which is also kind of makes sense. And we have a long list of all these common things, and we just add it. And then you can say, okay, now I want to be the taxonomy. After I apply these very simple rules, some account executive, or we can match the word account to sales, and maybe we have to do it careful so accountant won't become sales, but we can do some sort of these rules and then create now a much smaller list of titles and select the top K out of them in terms of how frequent they are, and say, oh, okay, look and behold, this is our list of titles. So, and then we kind of, for every person, we take, if a person is both a software engineer and a tech lead, then we take it and say, okay, this person is a software engineer and tech lead, and we say, well, now this person performs two functions. I'm sure all of you can immediately recognize there are some problems with it. So, first of all, if we are looking at a text-based approach, we sometimes, and remember, what I'm trying to do is, for example, help recruiters now find the people they're looking for. So software engineer and senior software engineer are now two distinct terms, right? So of course you might say, okay, but seniority is the word senior is just a seniority modifier. You can remove it. That's true, but it becomes now then more difficult. Like, what if it was staff or principal? And then if you just remove it in the word, like, if you're a principal at a school, then it loses any meaning. So we cannot just handle it. But so obviously some of these problems can be solved in a text manner, but I'm saying it's just not trivial. But without even addressing it, it's just for any practical purpose, we probably would not want to, any practical purposes besides seniority, we probably would not want to say that software engineer and senior software engineer do completely different things. They're probably they do something very similar, just one happens to be a little bit more senior than the other. The second problem is, and I hope you can see the text, is the synonym problem. Is the software developer, as a kind of programmer and software engineer, and and the list goes on and on. It's like software development engineer, like Microsoft and Yahoo. Microsoft and Amazon likes to call the people. In Yahoo, the people who write code are called technical Yahoos. So you cannot solve it with any NLP technique, right? Or like Google people like to call themselves Googlers. Awesome. Thank you, Google people. And the third one is architects. As you can see, this person, and it goes to our debate before, he is not building software. Okay, so believe me, I got my share of angry emails of please, please, please don't send me software architecture jobs. Stop, right? But the problem is very hard because there are companies that they put on LinkedIn an architect job, because when they think of an architect, in their mind there is only one type of architect. If I'm at IBM, of course architect means a software architect. And I already preluded, we can kind of base it on industry, or it doesn't have to be just text. But if we only limit ourselves to the titles, they're just ambiguity. And believe me, it doesn't end with architect. Our data science team, I think our favorite example is when we get jobs for mining engineers. Not great. So we must have some better way to do it, right? We need to come up with a better idea. And the idea comes from that, okay, we have our profiles. We have so much more information than just the text, the headline of what we do, right? We have the schools we went to, the previous company we worked for, and stuff that we wrote, and now the LinkedIn kind of profile, the things you can put on your LinkedIn profile goes on and on. It's like courses, certification, and so much. But one of the problem is when you kind of start working with this textual-based and also contextual-based feature vectors, and if the word feature vector doesn't say anything to you, just completely ignore it. But it's when you put it, it's kind of becomes this very messy data, because it's kind of hard to work with a vector that represents so many different things. One is a word I have on my summary, and the other is the school I went to, and how are they comparable, and all this sort of stuff. So we chose a much easier route, and actually it ended up working very well. And this route is endorsements. If you look at my endorsement, these are my top endorsements. It's pretty clear, even if you didn't know anything from my profile, my title, my company, it's pretty clear what I do for a living, right? And we even had a person on our team that his title for some, reason was mumble scientist. And I mean the actual words, mumble, M-U-M-B-L-E. And again, he was a very unique person. And so even now, but when we looked at his skills, we knew that he is, what's commonly, I guess, referred to as data scientist. And this is another example, head of search quality, Daniel Tankilang, who also spoke at Strata, and he was my first manager at LinkedIn. So Daniel Tankilang, karaoke aside, is pretty clear of what Daniel does, even though, head of search quality, he might be, training rescue dogs, right? It's just, not really clear, but I think if you look at it, oh yeah, he probably does kind of Google search, right? Okay, so the way we do it, and there is a Strata talk completely devoted to this subject, but I'll just touch on the overall kind of thing is, so we take the profile and we take all the stuff that people have on their profile, again, schools, companies, groups they belong to, stuff like that, and we run it through an inferred skills classifier. It's basically a kind of this naive-based classifier that people who work at these companies and had these titles tend to have these skills, and we extract skills from it. The problem with skills is they're somewhat based on stuff people put on their profile themselves, and people can put very aspirational stuff on their profile, like me calling myself this C++ guru. And so we actually then run it through like the endorsement, and endorsement is this recommendation engine that there's some crowdsourcing aspect to it where it's now different people tag you with those skills. Again, as I mentioned, it's not perfect, right? But if you look at both mine and Daniel's kind of endorsements, it's actually, in most cases, it gives us a pretty good representation of what that person does, and also it's not that easily to manipulate as, let's say, the previous step, which is just inferred skills. And then we create the skill vectors part, which, again, we just take these endorsements, kind of normalize them, and I will touch a little bit more about some additional stuff we do, but you can just think about it, and the bar chart represents their value. It's like L2 normalized, and you can just think about it as, okay, now every single person on LinkedIn is basically represented by this big vector of basically size of the top skill that we have, and he has some double floating point in how good this person is with the skills according to endorsements, blah blah blah. There are many ways to create this vector, but the important thing is now in the numerical vector that is also homogeneous and not like before that some cells represented education and some cells represent awards that I have on my text. Actually, every cell in our vector is now a skill, which is very convenient. And if you like to learn more about it, like I mentioned, there was a Strata talk about it given by Pete Skamrock and Sam Shah. And I put the link, and I will put the slides on my LinkedIn profile, so you don't have to memorize it, and you can go and learn more about it. Okay, awesome. Then our first thing that we want to do is create an ontology. An ontology is like a taxonomy where we say, okay, well, these are the stuff of people do. We internally refer to it as skill sets, right? It's like, or that these people have these skills, and we want to create some hierarchy. And the reason why we want to create a hierarchy, and I will. Is because if you think about it, it's kind of hard to say, okay, are these people doing the same thing? Because it kind of depends on context and resolution. Because our software engineer are the same, or a software engineer or hardware engineer are the same or not? Well, somewhat, right? Because they're both engineers. So on some level, they do perform a very similar function. But of course, the level at least, all of us engineers look at, no, it's like two completely different things. But, if you would ask, let's say a farmer about, do you think data scientists and, and analysts are the same? He'll say, yes, of course. What's the difference? But for us, oh my God, no. Or I know. So it really depends on the context, and that is why we created. And also for kind of different application, they want a different resolution of similarity. So we created this hierarchical taxonomy. And once you have this taxonomy, and say, well, I have engineers, I have software engineers, and also between software engineers, because LinkedIn data is so skewed towards, engineers, is we also actually separate, software engineers proficient with the JVM stack versus software engineers proficient in the .NET stack. It's not like we had this taxonomy before, it's just the clustering by skills kind of surfaced this up, that there are actually also distinction between engineers, between people with the same titles. And that's what's kind of nice. And the way hierarchical clustering works, you get this dendrogram, and if you want to extract clusters from it, one way is just said, okay, everything that has a similarity below a certain threshold, just split it. So you can think about if you see this red line and you just kind of pass this red line, we will get only the clusters that are together below that line, and they won't be grouped above this line. Again, it's this line represents distance, not very important, but kind of that is how you take a hierarchical clustering and get clusters. Sorry, one way. And then we do classification. The classification, so one thing important to remember here is unfortunately we don't have kind of labeled data. So for example, when I say someone is a software engineer on the JVM stack, I have this ontology that just was created. We don't have something that says, so we chose kind of here to do k nearest neighbors. And again, k nearest neighbors, for you who don't know, just say, okay, you choose a number k and say the 2 or 3 neighbors that are closest to me, that's what will be the kind of cluster assigned to that point. But not the main point, but kind of the main aspect of what I just talked about is more that usually in standardization tasks, there are two stages. One is you create some sort of taxonomy. And for skills, for example, it's RWire and Ruby on Rails are kind of go to the same node that, let's call it Ruby on Rails. Companies, IBM and international business machines are the same, and kind of you could create a canonical representation, and then you go through your entire data set and kind of classify it to your new data. In some cases, unfortunately not with titles, but for example with companies and stuff like that, we do have labels because people sometimes select about themselves from a pre-populated menu, but when we don't have, like in this example, we chose to use k nearest neighbors. Okay, so I touched on a very, very high level, and of course there is so much more work that went into that project, so let's just touch on some of it. One thing that you might have noticed from kind of my endorsements, that I have more endorsements for Java than for data science. Well, again, you guys, I guess, don't know me very well, but at least I would like to, perceive myself more as a data scientist than a Java engineer. Right? But unfortunately, I guess our recommendation algorithm plus my connections kind of decided to go some other way. And there is a very simple explanation. Java just happens to be a more common skill. People kind of, when they think about what do you do, they tend to endorse more for Java than they for data science. And our top skill on LinkedIn is Microsoft Office, and Microsoft Office is a particularly problematic example because unless you are like a Microsoft Office, somewhat expert, pretty much having the skills tells me nothing about what you do in your day job. So again, if you ever spend an hour in a data science class, you can probably guess, what's the solution to this problem in something that's called TF-IDF. Basically, we need to normalize all the skills, but how frequent they are. So here in our example, the documents are the members, the terms are the skills they have, and if we see that Microsoft Office or Java appears in many other members, unlike data science that is far less common, then we weight down its kind of weight in our skill vector. Again, pretty simple stuff. But TF-IDF is kind of occurs a lot in many applications. Another thing you might have noticed from my profile is I have endorsements for data mining, machine learning, algorithms, and data science, which all you might argue that are somewhat connected. And they're somewhat, pretty much, I don't know if the same, but, very, very similar skill. So the problem here is, let's say, take an extreme case where, let's say, I have only endorsements for data mining, and someone else have only endorsements for machine learning. I would like a similarity function that will not yield 0, but any mathematical similarity or distance function, well, let's use similarity, will always yield 0 because these are two completely different parts of the feature vector. And we would like to solve that. And here, there was a whole talk about it yesterday that was great, so I don't have to go in it. The way we decided to approach it is with called LDA, latent Dirichlet allocation. It's a topic modeling technique. I would highly encourage you to watch the session that was yesterday on Hardcore Data Science track about topic modeling. But basically what it does, it says, okay, I have topics and I have terms that belong to a topic. So basically, after you run this algorithm on our skill skills, you get that, in a very high probability, data mining and machine learning kind of belong to the same topic. The topics don't have to be named. They just have, they belong to the same topic. That's enough. And then I can actually get also a much smaller, because it's also a wonderful dimensionality reduction technique, but I get a much smaller granularity of skills. And I say, well, skills that are around this concept of data mining and machine learning, and I don't have to get me and someone else that only has machine learning skills will be very similar, unlike before. Of course, with any algorithm, it never works as well as promised, but there are some tweaks that can be made, and it actually produces pretty decent results. And the third one is, again, in my example of Daniel, is karaoke. So he has a lot of endorsements for karaoke, but it doesn't really says anything about what Daniel does as head of search query at LinkedIn. So you can see from this head title, it's we want to somehow detect the anomaly and realize that karaoke has kind of really nothing to do with his other skills. So what we create is this co-occurrence graph where we say, okay, let's say for every skill, what other skills on all the LinkedIn profile it's kind of co-occurs with, and let's kind of cluster it and visualize it. Unfortunately, I couldn't find, for some reason, the original visualization we did, but the end result looks something like that, right? So the bubble represents how big how common the skill is, and the kind of colors only, and more important, the distance between them presents, okay, so these skills belong together while other are not, and you can imagine that karaoke will be on the red side and all the information retrieval skills will be on the blue side, and now you have a new you can use some metric that is based on this kind of representation that, okay, for Daniel Tunkelang specifically, karaoke is probably an anomaly, and we shouldn't include that skill in his in his skill vector. There is also in previous Strata given a very good talk about anomaly detection by Ted Dunning, and again, I highly encourage you to watch it. But basically, like I said, it's more about kind of data munging and cleaning than very fancy modeling techniques. It's just common sense, I guess. So to summarize, and I'm running out of time here, so hopefully what you realize here that the three things I touched in my what's in it for you is that user-generated content from a lot of members that happen to create their own data creates a lot of problems that we need to fix. The second thing is data cleaning is just so much more than what we usually think about data cleaning. Our team, we have a team of we had a team of 5-6 people that all they did is this standardization work in order to make this economic graph a possibility. And my project, for example, I work on this title for a year, and I in parallel work on also seniority stuff, like understanding that how product manager and engineering manager relate. Are the same seniority, different, or whether principal engineer is higher or lower than an engineering manager and stuff like that. So it's a lot of cleaning and standardization that needs to be done. So, and it's a very hard and important task because all of our recommendation algorithms at LinkedIn, and we have a lot of them, actually use the data created by the data intelligence team. And the third one is, a lot of time, language is just a problematic. It's just, it's a way that we kind of develop that we are as human beings, we have a lot of context to understand it much better. However, if you have some way to go around it, then please do so, because just, even the best NLP team will not solve some of the problem that languages have. And again, like another example that is not my work, instead of, if you're using sentiment analysis on some text, instead of trying to extract sentiment, and you can just ask the users, okay, like rate it on a scale between 1 to 5 or something like that. So look for kind of these signals, because language tends to be hard. So that's about it, and that's just kind of was my summary. So if you have any question, please kind of start coming to the mics. And just the final words, and as you can see, there's some transition happening. These are my great PowerPoint skills that I wasn't endorsed for, unfortunately. But if you're connected to me, please do. And so I now work at Salesforce, and we have now one of the greatest, basically pretty much every business transaction in the world as a data set to play with. And it's not that this. Salesforce also owns a lot of other companies, and Radian6 basically has the entire Twitter feed, right? And RelateIQ and ExactTarget, which is the kind of $2.5 billion acquisition that Salesforce made last year, and Data.com, who I don't really know what they do, but it sounds they have data. So if you just kind of interested, please talk to me, join us. We have another great people already working with us. DJ Patil, who practically coined the term data science. Gary Flake, who started Yahoo Research, and also then was personally recruited by Bill Gates to do the same very similar thing at Microsoft. And Bo, who is, I don't know if he's here, but he will talk tomorrow, and please go, he's awesome, and listen to his talk. And thank you. Yes, please.
So my question was about how you evaluate the different approaches that you described. So you talked about different ways in which you could kind of do the classification and arrive at someone's job or their occupation. How do you use or evaluate which combination of approaches works best? Okay,
so first of all, it's a great question because we really struggle with it. I think we spend a lot of time, and I actually have had some slides here, but I decided to hide them because when I was practicing, I just couldn't go through all of them. But there is first thing there is one thing we need to understand. There are two very distinct things here. One is we doing the ontology generation, and the second thing is the classification. Or two completely distinct tasks. One is completely unsupervised, and the other can be supervised. So and they have to be evaluated differently. So for the clustering, the unsupervised one, it's unfortunately, like with unsupervised, we have some, metrics how to see our clusters, but pretty much any metric that we tried wasn't very good one because like cluster coherence and stuff like that are just not great metrics to understand whether I cluster 300 million members well. It's okay, it will give me a number, but then what? So we actually had to eyeball a lot, and we just did a kind of internal crowdsourcing. And the reason why we did internal crowdsourcing is because the other thing is, and also related for both problems, also for the classification, unfortunately we could not find outside experts that could help us with this task of title. Like for example, I guess a lot of people don't know that account manager and salesperson is the same thing. Or some other stuff that you need to have some domain knowledge in order to do so. So we kind of use the experts to evaluate the cluster. And the classification is, again, it actually has a very similar problem. Okay, so we decided to mark me as a data scientist and not a software engineer. How do we know whether it's correct? Then we used some metric here that it wasn't perfect. Nothing that we could do, unfortunately, will be perfect, but we had the assumption that we wanted to say that people usually stay within their own kind of functions. And what we did is look at all the career progression of people and we say, okay, we want to classify all these positions to be somewhat similar. So if I now move from, being a data science lead to a director of data science, I want these two to be classified to the same kind of cluster. Of course, like I said, there are problems with that method, but what's nice about it that it didn't require any crowdsourcing, and it gave us at least a number that we work on in order to improve it. Any other questions? Yes.
Yeah. So great talk. Interesting that you talked a lot about the canonicalization or sort of the normalization of the different kinds of data fields. I think was really interesting, and having the data enables you to really do that. If you don't have all the data set, it's obviously very challenging. You can take a sample. I guess one of my questions is there an opportunity in the near future for LinkedIn to maybe expose an API that would give you that sort of semantic structure, that ontology, if you will, and kind of let you then take that and even potentially allow some people to sort of recommend enhancements to that?
Yeah, so first of all, thank you, well, both for your comment about the talk and the question, because it's a very good question, and it's also a problem that occurs a lot. So I was talking to Kira yesterday from Sales Predict, and she gave a talk, and she actually faced the same, a very similar problem, and say, okay, why are so many people? And I know of other companies that solve a very similar problem, and say, okay, let's stop solving it. However, there is a problem that, for example, LinkedIn's dataset looks very specific. It's very much skewed towards, technology sector, right? Because you can go on the Department of Labor site and get their ontology, but you can see they have like a lot of levels of agriculture workers, right? Livestock versus wheat farmers versus stuff like that. Which on LinkedIn, we just genuinely did not find this distinction because we just don't have a lot of these people. So the data set that we currently have is a very LinkedIn specific. Like for example, many other companies do not need to differentiate between software engineers and embedded software engineers and software engineers that work on the .NET stack and the JVM stack. But unfortunately, yes, it's like I'm saying, recruiters actually do care about that distinction, even though both people call themselves software engineers. Right. So it can, I don't know if LinkedIn might regard it as, it's like a competitive intellectual property. Right. So I don't know about this API, but like I said, unfortunately, I'm not sure how it will be useful for other companies.
Right. So then in Salesforce, I guess it'd be similar for looking at companies, industries like the SIC or whatever the code is.
Yeah.
It's going to be a similar challenge. Do they release their own sort of semantic view of the world?
Definitely. And I was actually kind of half joking about what data.com does. Data.com is the new name of a company that was used to call Jigsaw. And what Jigsaw did is this API, it's like creating a wiki for executives. You go there and you put who is the CEO of Microsoft, and people kind of curate, and then everyone has access to it, and consultants use it. So definitely, like data.com has the same problem, and I know the people who actually work on that problem inside Salesforce.
Thank you.
Yes.
Might be a related question. Any plans to expose that data back to the user? So you have a skills vector about the user. Can they ever see like a more accurate categorization of what their own skills are?
Well, first of all, the skills are exposed. The skills that you have on your profile, these are actually standardized skills. For endorsements, we might have different, because if someone endorsed me for binge eating, we actually will display it because they're actually, it's kind of funny and people use the endorsement this way. But however, your inferred skills are standardized. So if you look at I think we have like this skills section that you can look at. They're all, if you're asking whether I can get the entire list, it's very similar answer to what I gave the gentleman here. The LinkedIn skill set is extremely skewed towards, towards actually the tech sector. It's like, for example, for many people, they don't care about, Java 7 versus Java 8, but, LinkedIn might find, people actually want to use that as two different skills.
Yes, a slightly different variation is, do you ever standardize like IBM to one title? Or
yes, definitely. If you will find someone that has TJ Watson Center on his profile, and you will see a logo of IBM next to it. Okay, my time is up, so thank you again.